Hi everyone, welcome back to my channel. If you are new here, I am Sushmita and on this channel we learn coding concepts in a simple and practical way. In this video, we are going to understand space complexity, what it means, why it matters and how to calculate it using easy examples. If you already know time complexity, this video will help you complete the picture. So let's get started. Now, let me ask you something. Imagine your code runs really fast, no time limit issues, everything looks perfect. But the moment you run it with large inputs, say 10 power 7 to 10 power 10, the program crashes. Not because it's slow, but because it runs out of memory. That's exactly the problem space complexity helps us understand. So, what exactly is space complexity? In simple words, space complexity tells us how much memory a program uses as the input size increases. Just like time complexity measures execution time, space complexity measures memory usage. So, the input grows, how the memory grows. That is what we analyze in space complexity. Why space complexity matters? Now, you might think my system has enough RAM, why should I worry about memory? But remember, memory is always limited, and online judges have memory limits. For most of the coding platforms, memory limits usually fall in this range, that is 256 MB, 512 MB, and it is 1024 MB, that is 1 GB. So 256 MB is very common by default in most of the coding platforms will be seeing this, and 512 MB is common for harder problems, and 1024 MB or 1 GB it's like very rare, it's mostly used for advanced problems. And the third reason would be apps must scale, that means like real applications cannot waste memory as memory is very costly. So even if your code is fast, if it uses too much memory, it can fail with memory limit exceeded or crash completely. So that's why good code must be both time and space efficient. So let's jump into its components. So space complexity mainly has two parts. The first one is input space and the second one is auxiliary space. So input space is nothing but some memory required to store the input itself. For example, here we have an array of size 5. So to store the 5 elements, we definitely require 5 blocks of memory, which is unavoidable, right? So that is called input space. And the second one is auxiliary space, that is the extra memory used by the algorithm apart from the input, which includes extra variables, extra arrays, and recursion stack space. So when we talk about space complexity in interviews or problem solving, we usually mean auxiliary space, not input space. Let's understand more about this space complexity from the examples. So the first one here we have is a simple for loop, and we have an variable which is declared outside the for loop and assigned a value 0. So for each iteration the sum value is getting incremented by I. So here no matter how large n becomes, because we are not assigning another variable inside a for loop, we are just changing the value of the sum variable which was already declared outside the for loop. So the memory usage does not increase with the input size. So the space complexity here is big of 1, which means constant space. Let's see the second example. Here I have declared an array of size n. So as an n increases, the memory required for this array also increases, because to store input size say n equals 9, so I need 9 blocks of memory. So as n increases, I need more memory blocks. So here the space complexity is big of n, which we can say as linear space. And the third one, the most important one, which is recursion and hidden space usage. Here we have a simple function and we have a base statement here, and again we have a function, the same function call itself, where the input is decremented by 1. So this is nothing but a recursion because the function calling itself. So at first glance you might think there is no array here, so space complexity should be big of 1. But that's not correct. Every recursive call uses memory in the call stack. Let's say if n equals to 5, so it takes the memory in the call stack. So first function 5 is called, and then since it's not equal to 0, f of 4 is called, f of 3 is called, f of 2 is called, and until it reaches f of 0, it returns back to all its functions. At max here, if you see, 5 function calls have been made and it is placed inside the stack. So the stack grows with the input size n. So here we say that space complexity as big of n. This is why recursion always consumes extra space. So to quickly summarize this video, if you use only few variables, it takes big of 1 space. If you use an array of size n, space would be big of n. If recursion depth is n, then the space is big of n. So if the recursion depth divides input by 2, then the space would be big of log n. So to wrap it up, space complexity tells us how memory usage grows with the input size. Always remember, loops mainly affect time and arrays and recursion affect space. So I hope this video really helped you to understand what is space complexity with some simple examples. See you in the next one. Thank you.